Okay, we're going to continue talking about our unit circle, and in this next session today, we're going to talk about radians. When we talk about radians, we're going to talk about kind of the math that we do with trigonometry. We're going to stop thinking about degrees so much and start thinking about radians. And where that comes from is if you think about what the circumference of a circle, if I were to draw a circle right here, what would its circumference be? Well, if you think about it, circumference equals 2 pi r. Well, what's our r? On a unit circle, the radius is going to be 1. So if the radius is going to be 1, it's 2 pi times 1, or just 2 pi. So if we were to take a circle and go all the way around, it would be 2 pi going all the way across. Now from its starting point, it's going to start at 0. But once you go all the way across, it's going to get to 2 pi. So now we start saying, well, what's the distance for all the other points here on the axis? Well, this right here would be half of that. Well, what's half of 2 pi? Half of 2 pi is just pi, right? Okay, well, what's half of pi? Well, that would just be pi over 2. And this would be 1.5, right? Because you have 1 pi, 2 pi, this would be 1.5. So we're going to go 1 and 1/2, and we're just going to, take that into a improper fraction. That's just going to equal 3/2. Or we're going to write 3 pi over 2. Okay, so this is stuff that we just want you to memorize. Okay, now the other thing that's really important, and maybe I'll do a video on the how later on, but we just want to know the what for right now to get you guys moving on this. If we were to keep dividing these in half, for example, if I'm drawing the circle and we kind of stop right there, and this is 45 degrees, well, you'd agree that this is halfway in between 0 and pi over 2. Well, what's halfway between 0 and 1/2? And the answer is 1/4. So this right here would be pi over 4. So at 45 degrees, instead of 45 degrees, we're now going to say pi over 4. Okay? Now, we can do some things to show you the 30 and the 60 degree, but I just want you to trust me on this one. 30 degree, we're going to call this pi over 6. And 60 degrees, we're going to call pi over 3. Okay? And so, one way, there's different ways to think about it. The 30 goes with the 6, the 60 goes with the 3, so they kind of alternate the 6s and 3s. Another way to think about it, pretend these pi's were 1s. Okay, between 1/6 and 1/3, what's the bigger fraction? Okay, well, 1/3 of something is bigger than 1/6, and so the bigger one goes with 60, the smallest one goes with 30, and the Goldilocks, the one in between, goes with the 45. I don't care how you memorize it, but this is what you want to memorize. So once you memorize this, we can start going and learning all the others. Now I think I'm going to put that in another video, just because we can stop and take our breath after this one. Because I want to show you one more thing on this, okay? We know that this is 0. I'm going to take the 0 away, okay? And then we'll do reference angles and stuff like that on the next one to show you how that works. But I also want you to think about this. Now we're going to have to do portions. So we know that 30 degrees here is going to be pi over 6. 45 is going to be the pi over 4. 60 degrees, that's going to be the pi over 6. Well, what happens when we go here? What happens when we go here? Well, we're going to start adding, subtracting these fractions. We're going to have to subtract a third, subtract a 6, add a 4th, do things like that. And it starts to get a little bit confusing, especially if you don't love fractions. So here's what I want you to think of, and this will be the last thing we do on this. Pi can be written many different ways. So if I want to write pi as, say I'm going to do some math with the pi over 6. So I want this to say something with 6. Well, watch this. 6 pi over 6. 6's cancel out, I'm left with pi. All I did was write it with a 6 on the bottom. How about with a 4 on the bottom? 4 pi over 4. How about with a 3 on the bottom? 3 pi over 3. So those are just different ways that you can write pi that's going to help you work with the fractions. And I'll do examples in the next video, but this would be a really great thing for you to just kind of realize. And then same thing here with the 2 pi. If I want to write this, since I'll kind of go out with I'll start with the 3's, okay? So now I want 2 pi, but a 3 on the bottom. So if I want a 3 on the bottom, and I want this to be equal to 2 pi, I'm going to write a 6 pi right here. So 6 pi over 3 is really the same as 2 pi once you divide 6 by 3. If I do it 4, that would be 8 pi over 4. And with a 6, it would be 12 pi over 6. So it's just a different way. What does that equal? 2 pi. What does that equal? 2 pi. What does that equal? 2 pi. Why does that matter? Because reference angles, think about it, when we had 180 degrees here, we would subtract 30 from 180, or we'd add 30 from 180, or we'd subtract 45, or we would subtract 60, or we'd add 45, and all that. Right here, we would subtract 30 degrees from 360, or we would subtract 60 degrees from 360, and this is what we would do to find our reference angles. Well, we're going to do that with radians, except for now we're going to have fractions. And with fractions, it's way easier if we have our denominator the same. So we want to think of pi and 2 pi as having these denominators as well. So I'll get a sheet on for you to download so you kind of have all this. But I just want this here right now. Stop, take a breath, memorize this. Do not go on into the next video until you feel like you have this memorized and you have the 4 points of the axis memorized and you sort of understand this conversion thing. If you get that, you are ready for the next video, and I'll see you there.